Good morning. I'm Habib Dagher, Director of the Composite Center at the University of Maine and Director of the Transportation Infrastructure Durability Center. We welcome you to the 2021 Symposium on New England Railroad Infrastructure, Challenges, Solutions, and Opportunities. As we move towards a greener infrastructure for our country, the railroads are going to be key to this greener infrastructure that we need to build. The purpose of this symposium is to look at the challenges and solutions and opportunities for the railroad infrastructure in the New England area. As you all know, the Senate passed the $1.2 trillion infrastructure bill. As part of that, there's $66 billion for railroads, which would include upgrades and maintenance of America's passenger rail system and freight rail safety. Senator Susan Collins, as you see here, was key to doing that and getting a bipartisan group to move this infrastructure bill forward. So hopefully a lot of good opportunities for both roads, bridges, as well as the railroads as we move forward. Our program today starts at 9 a.m. and ends at 4 p.m. Following my introduction about the conference itself and the work that the Transportation Infrastructure Durability Center is doing, we'll have a keynote talk from Sean Woody, who's the FRA Railroad Research and Emerging Research Needs presentation. Following that, at 10:30, we'll have a session on needs and challenges for a railroad industry. At 1 o'clock, we'll have a keynote speaker. That's a Deputy Commissioner for the Con DOT to talk about the future of passenger rail in Connecticut. At 1:30 p.m., we're going to look at forensics and technical advancements panel on the railroad industry. And the last session at 2:45 is on solutions and opportunities for railroads in the New England area. And then finally at 3:45, we'll have some closing remarks. As we all know, all transportation infrastructure industries are facing unprecedented barriers as well as opportunities, particularly with the new infrastructure bill. But as part of that, the railroad is seeing significant challenges. And we hope that this symposium this year and in future years will help focus the light on the needs of the railroad industry in the Northeast area and help us all work together to try to help resolve some of these issues, both researchers, industry, as well as the railroad owners. The Advanced Structures and Composite Center at the University of Maine is a 25-year-old research center established by the National Science Foundation. It's the largest university-based research center in the state of Maine. We have 260 personnel, and we focus on advanced materials for use in infrastructure. We work on design, manufacturing, and testing of infrastructure systems under one roof, which allow us to quickly not only design new products, but also build them in the lab, manufacture them in the lab, and test them in the lab. That allows the ability to go through the design cycle very quickly and reach optimum solutions a lot faster. The center has a 100,000 square foot lab, and we've had 10 spin-off companies from our laboratory. So we're very keen on taking technologies developed in this lab and making sure they work for industry and for society. The center has had over 30,000 visitors and 1,600 media stories. And our motto is none of us is as smart as all of us. The goal is to get experts from a variety of fields working together to solve problems. Within our lab, we've had experts from 35 different disciplines over the last quarter century work together to help solve some of these challenging transportation and infrastructure issues. These are our clients and partners from across the globe. Our strategic plan developed in 2020 is called GEM, and it's focused on green energy and materials. So our goal is to bring green energy and green materials to our region, to our country, and to the world. So we look forward to work with you on the railroad side to try to get there. Examples of technologies developed in our laboratory recently is called the G girders, or the genius girders, if you wish. And this girder has been designed using life cycle in mind. Rather than designing the lightest girder that you can, or the largest bridge system that you can, we really looked at the entire life cycle from what does it take to fabricate the girder? What does it take to transport it to the site? How do you erect the bridge system on the site. How do you maintain it during its lifetime, and how do you work on removing it at the end of its lifetime? So looking at that, we designed a new girder system made out of composite materials that is shaped like a U-shaped beam, as you see here. And notice that the girders are stackable. And the reason for that is to reduce the constraints, shipping constraints for girders. And in this case, on this stretch bed, that's a 70-foot stretch beds, it can carry enough girders for 4 70-foot two-lane bridges. And that's because the girders are light. They're about a quarter the weight of a typical steel girder, but they also nest together. And the girders are light enough that you don't need heavy cranes to actually install them. The decking on that system is a concrete deck, and that could be pre-installed, or part of it could be pre-installed before you come in. You'd have a longitudinal deck and longitudinal joints between the deck sections, or you can have a transverse deck panels that could be installed and a transverse joints in the deck panel. But what's unique about the technology is that the deck is removable. So after reaching in the Northeast, of course, the durability of decks is a big issue for us because of the use of salts and freeze-thaw cycles and so forth. And the decks might last 40 plus years. We're able, in this case, to remove the deck, unbolt it from the girders, and then put a new deck on without having to jackhammer the concrete off. That's an example of how we're thinking long-term with these systems. The girder has been commercialized right now, and there's a company in Maine, Advanced Infrastructure Technology, that's building these girders and shipping them across the country. Let's focus a bit on the Transportation Infrastructure Durability Center. That's a federal highway funded research center in Region 1. That's the center that includes the different states, the Northeast state, New England states that you see here. And the center has currently 53 active research projects across all states, across all universities in the states. We're very keen on working with industry and meeting DOT real needs and taking technologies out of the lab and into the real world. So we're very pleased that every one of our projects has a DOT technical champions, every one of the 53 projects that works very closely with our researchers to ensure that the research is heading in the right direction, and it has practical uses that the DOT can take away from and implement in their infrastructure systems. So that's a different way of looking at research. This is where the customer of the research is embedded in the research process from day one to ensure that the results achieve their goals. The Transportation Center is conducting transformative infrastructure durability research in 4 different research thrusts. The first is monitoring and assessment. So it's very difficult to figure out how you can enhance life if you don't know what you have, what the infrastructure looks like. So we're looking at next generation methods to assess the current infrastructure. These are sensors and sensor technologies and so forth. They will tell us more about our current infrastructure, railroads and bridges and so forth, so we can figure out how to better improve them and enhance them. The second thrust area is developing new materials for longevity and constructability. What are better materials that we could use, whether better enhanced concretes, better enhanced advanced materials, better enhanced steel materials and so forth that could be used to enhance durability and enhance constructability of these systems. The thrust area 3 is new structural systems, or new, whether it's railroad bridge systems or highway bridge systems, or waterfront port systems that can enhance constructability, longevity, and constructability. So it's not only new materials, but also new systems, because a system approach is needed to allow us to reduce damage and enhance longevity of these systems that we install, not just the materials that go into these systems. And finally, the 4th thrust area is connectivity for enhanced asset performance and management. How do we use new technology, digital technology, to be able to learn more about all of our assets as they're operating in the real world? So these are the 4 thrusts that we work on. We have 248 students across all these different states working on all these 4 different thrusts. And we have 55 faculty and staff researchers across 6 universities involved in the Transportation Infrastructure Durability Center. And these are the key players within the center. And there are, of course, a lot of other players, but I'd like to start by thanking our Transportation Infrastructure Advisory Board, the DOT Advisory Board. That's key to moving us forward. And they're the leaders within the DOTs that are interacting with the Transportation Center. And they're the ones who identify the problems that the DOT is facing, bring them to our researchers, identify champions within the DOTs for all the problems that get embedded with the research teams as we move forward. So I'd like to thank Dale Peabody, the advisory board chair, who's been absolutely fantastic and the heart and soul of our interactions with the DOTs. From Connecticut, you can read here, Connecticut DOT, New Hampshire DOT, Rhode Island DOT, Mass, and Vermont DOT. We'd like to thank every one of the advisory board members. In terms of the management team members, we have Jim Bryce, who's a program manager, who's spent his whole life in the real world, building bridges and constructing things. And he's coming in and bringing a real world experience to the research that we do. And then we have a variety of thrust leads in each one of the 4 thrusts that I've described. We have a thrust leader at the University of Maine, Dr. Bill Davis, Dr. Roberto Lopez Anido, Dr. Aaron Gallant, and Dr. Jonathan Rubin. We also have within each university an institutional leads, and you could see who they are here, and they've been critical to coordinating research within each university and bringing that back to the central advisory board. And then we also have some key members who actually make this work day to day, and that's Amanda Collymore, Vu Fan, that work day to day to make sure that all the researchers have the tools that they need. This is an example of some of the research that we've discussed earlier. This is a Girder Bridge system that's been already implemented in the field. This is a technology developed at the University of Maine, and it's been enhanced under the Transportation Center work. And I've described it earlier as very lightweight girders. And you could see here the real results of the research. This is actually a truck carrying a bridge to Fort Myers, Florida, a 2-lane bridge from Maine to Fort Myers. And notice how the girders stack together. They're very lightweight and easy to transport and easy to install. And this is one of the bridges using this technology that was installed in Maine, in Hampden, Maine. It's a 70-foot long girder bridge. And because the girders are so light, the contractor was able to actually put the 2 girders together and lift them with a relatively smaller crane and place them across the abutments. These girders were all placed in a single day, including utilities under the bridge. And the bridge is designed for a 100-year life. As I said earlier, you can see the bolts that connect the concrete deck panels to the girders. So the idea is at the end of the life of the girder, at the end of the life of the concrete deck, you can actually unbolt it rather than jackhammer it off and put a new deck on. So this is an example of research taken from the lab and into the field and being used in real life. And I'm very keen in a transportation center to get real solutions that get applied in industry. So I go back to, I'm going to cover a few highlights of some of the work going on in each of our 4 research thrust areas. Our first research thrust areas are monitoring and assessment for enhanced life, other bridges, better methods to monitor bridges. We have 15 active projects in better ways to monitor and get data from our infrastructure out there. And that's an example of field load testing on one of the bridges that we have. Dr. Bill Davids is managing this thrust area. And one of his projects was to conduct a more enhanced rating methods for bridges. So bridges that otherwise under a coast-based rating would have failed. By doing a more enhanced rating, including a load testing, we're able to extend the life of these bridges. Because of this work that Dr. Bill Davids have pioneered here, we're able to extend the life of about 2/3 of the bridges that otherwise would have by code would have a failing rating factor. So this is a way to kind of buy time, if you wish, for our DOTs as we find the resources to replace some of these bridges. This is another project done by Dr. Yu at UMass Lowell that's looking at electromagnetic detection and identification of concrete cracking in highway bridges. So different tools that we're using to better enhance and understand where the concrete cracking is taking place, and it's using electromagnetic methods to do that. This is another project looking at better understanding the in situ properties of bridge assets. And this is a distributed fiber optic sensing system for monitoring bridges, both railroad as well as highway bridges. And that's being done at UMass Lowell by Dr. Wang. This is I'm going to research thrust area 2. Research thrust area 2 has 14 active research projects. And one of them is being conducted by Dr. Roberto Lopez Anido, Dr. Andy Gupi, and Dr. Berube at the University of Maine. And this particular bridge has the Penobscot-Narrows Bridge. It has 3 pairs of non-corrosive carbon fiber composite strands installed in 2007. And it is like a living laboratory that we're collecting data on to compare the performance of carbon fiber strands versus steel strands in an environment like that. So as you know, these carbon fiber strands are lighter than the steel strands and can potentially enhance or the life or increase the life of the state system. This other project also being conducted by Dr. Roberto Lopez Anido and Dr. Bandari, and in collaboration with the Pre-Stressed Concrete Institute with Rita Saradarian. And the goal there is to use 3D printing to produce precast concrete formwork or tooling for a variety of transportation assets. So if you have complicated formwork that you need for concrete, it may make sense to 3D print it. And this is an example for a railroad project where we've designed and printed precast concrete formwork and CNC machined that formwork for a very complex piece. And you can see the piece here on the upper right-hand corner that's been 3D printed, and you can see the complexity of the piece. This particular project utilizes 100% recyclable formwork as well. So the one major advantage of this formwork is when you're done with it, you can actually grind it up and put it back into the printer. This project is also being conducted by Dr. Roberto Lopez Anido and Dr. Bandari and Alex Mann. And this project at the Maine DOT, and this project is a brainchild of Alex Mann and the Maine Department of Transportation to install diffusers in culverts that will allow to use a Venturi effect to increase the culvert capacity and compensate for losses due to liner retrofits. When you retrofit a culvert, you reduce the flow inside the culvert, and this particular unit that we 3D print, or this diffuser that we 3D print, allows to increase the flow through the culvert, but also reduces the outlet flow velocity to minimize erosion. And you can see here it's printed in 3 parts, and then it was installed at Thorndike, Maine, by the Maine DOT, and there's other projects we're also installing these in other states as well. And this 3D printed diffuser is also printed using all bio-based materials. So the resin used to print it is derived from corn, and the fiber used to reinforce the print is derived from wood. So basically, this diffuser is made from corn and wood, and it's 100% recyclable. So at the end of its life, it can be completely ground up and 3D printed again, and hopefully will allow us to enhance and increase the life of culvert systems that we're all concerned about with the extreme storms that we're seeing in our region right now. The research thrust area 3 is looking at new systems for longevity and constructability. We have 11 active projects that are testing, monitoring, and developing new bridge system. This happens to be the Hamden Bridge that I showed you earlier, and this is a new complete bridge system to reduce the life cycle costs and reduce the carbon footprint of bridges. Another project is a project conducted by Dr. Shin at Western New England University, and is to prevent stress-induced failures in pre-stressed concrete railroad ties. And there's quite a bit of work ongoing in there to see how we can enhance the longevity of concrete railroad ties. This next project is a project being conducted with Dr. Mao at UMass Lowell, and it's a modal identification method using video processing techniques to look at the durability or the performance of a bridge. You can see here in the lower left-hand corner a test set up at a bridge site where a modal test was conducted on a bridge during operation, giving us a baseline of information about the bridge. And you can come back to that bridge in future years and repeat the test and better understand how the bridge properties are changing over time. The last research thrust area is enhancing connectivity and to enhance asset performance and management. How do we use new technologies, digital technologies? How do we use new network systems to better understand what our assets are doing out there in the real world? And we have a number of projects. We have 8 projects ongoing in there. One of them is a highly automated vehicle and bridge infrastructure project. One is involved in cybersecurity risk assessment at UConn. Another project is looking at bridge stream network systems to identify sensitive structural, hydraulic, and landscape parameters for planning flood mitigation at University of Vermont. Very important projects, as you know, in Vermont. There's been some significant flooding that has taken place, and that been a big issue. How do we better identify which systems are sensitive to flooding and try to do something about them is one of the projects that's being done at the University of Vermont. One of the projects at UMaine that we're doing is using data from COVID-19 traffic patterns to better understand what kind of traffic patterns, how they've changed during COVID, and what does that tell us about the impact on the transportation infrastructure. We're also looking at road salt impact assessment at UMaine and so forth. And there's a project at UConn that's looking at proactive and intelligent risk management of infrastructure systems. And you can see here a University of Vermont graduate student that's working on taking stream measurements in the field that would feed into flooding mitigation planning projects. So that I'd like to thank you and also thank our conference planning committee. This couldn't have been done without the group of 7 folks that you see on the screen right here. Jim Bryce, the program manager for the Transportation Center; Dale Peabody, the director of transportation research at the Maine DOT; Dr. Mala at UConn; Dr. Shin at Western New England University; Amanda Cullimore, who's the transportation program coordinator, but also a legislator in the state of Maine; Mr. Wasson, administrative specialist; Megan Collins, and also Tracy Bentigui, who's the communication specialist and has been at the heart and soul of putting together the program. That brings me to the next part of the program. In 2 minutes, you'll be hearing from Sean Woody, who's the chief of track research, the track research division of the Office of Research, Development, and Technology for the Federal Railroad Administration. It's really a great pleasure and honor to have Mr. Woody here with us today. Sean Woody has been with the FRA Office of Research, Development, and Technology. He's the chief track research of the track research division. The track research division's team of program managers initiate and develop projects that address the most pressing safety needs in the railroad industry and also oversee the FRA's Transportation Technology Center. Sean joined the FRA in 2020 following a 29-year career at Norfolk Southern. He held various positions in Norfolk Southern's research and test department, primarily focusing on safety, inspection, and operation issues in the transportation engineering and mechanical department. It is truly a great pleasure for us to have Sean Woody open up our conference with the keynote speech. And with this, I'll hand it over to Sean Woody.